Welcome to Data Storage Made Simple. Keep watching to find out why storage has become such a big challenge and get an introduction in plain English as to some of the solutions the IT industry has to offer. Even for organizations with the shiniest servers and storage, it's still a problem. IT budgets are typically flat, and yet the rampant increase in data storage costs continues unabated. So to avoid catastrophe, we have to look at ways to curb storage costs. Consider DynoCare, a fictional company, but with real challenges. At 9 in the morning UK time, an email arrives. Today is the launch of the new Customer Relationship Management System, or CRM. In each inbox is a mail from marketing with a 55-slide PowerPoint. Being diligent workers, all 500 staff across the UK save the attachments onto their personal network folders for future reference, next to the copies of the manuals from earlier in the month. The workday now includes the logging of customer conversations into CRM. There is much new data, and because it may be important, it has been replicated to a secondary data center. Just as the UK workers are leaving, the US workers are coming online. The events of the day repeat. 8 hours later, in the middle of the UK night, lights start flashing and motors start whirring. Backup has commenced. 5 years ago, a major technology refresh was combined with a consolidation project which introduced network storage, SAN and NAS technology. This pulled the data from the old servers and put it into one highly resilient system. Backups had been taking 15 hours to run and were eating into office hours and hitting systems performance. The new architecture stages backups by first copying data to an area of disk, then backing this up to tape. This means users can carry on working, writing to the primary disks while the backup runs from the static copy. This eliminates backup window issues, meaning that if a backup does run into office hours, it's no longer a problem. To protect against a major system failure or other disaster, the server and storage infrastructure is replicated on a remote second site. The big problem 5 years later on is that the capacity limitation of the storage system means that a major investment may be needed to cope with the ongoing growth. DynoCare has 30 terabytes of storage at the primary site, growing at 1 terabyte every month. This setup is replicated onto the secondary site. As new applications are rolled out, IT allocates storage based on estimates and include headroom for growth. This leads to significant sections of disk being allocated but not actually used. To help minimize backup windows clashing with office hours, data is copied to an area of disk first, then later to tape. Significant space is required for this. Many files which are stored on the system are duplicated, multiple instances of the same data. These duplicates can often take up to 5 times the space of the original data. The majority of the data has aged and is little used. It is needed for reference occasionally, but it is only the live, changing data which is providing real value to the organization, and yet costs are incurred by all the storage. To help solve these issues, it is useful to consider data as having a life cycle with 3 phases. The first is creation. Data can come from 2 sources, the first of which is people. People entering data into PCs, laptops, mobiles, etc. The second source is IT systems. This is where machines create data on behalf of people. CCTV systems, warehouse control, phone systems, security software, the list keeps growing. It all needs storing. You can see that even if the rate of data creation was steady, the demand for storage would be an ever-increasing one. You can imagine that the older the data gets, the more likely it can be deleted. There is an increasing number of rules which govern how long data must be kept, whether for corporate governance reasons, to resolve disputes, or for legal compliance reasons within regulated industries, which now includes all American-owned companies because of Sarbanes-Oxley. Information is the meaning behind data. It is information that has value, not the ones and zeros of data. Information Lifecycle Management, or ILM for short, is a concept which firstly classifies information based on characteristics such as criticality, performance, age when last accessed, and security. The information can be stored on tiers of storage which best reflects its needs. ILM theory says that as information ages, it tends to lose value and can be moved down the tiers to the point where eventually it can be deleted. There is no right or wrong way of tiering information, but here is an example of how it could work. Tier 1. This would be live, regularly accessed data which needs high performance and high resilience. Hard drives will probably be SAS or fibre channel technology. Tier 2. This is for less critical and slower changing information which is nonetheless important. This tier often consists of SATA hard drives which are cheaper, slower and higher capacity than fibre channel or SAS. Tier 3. This is often set up as archive. It may also be based on SATA disks, but the key thing is that the information tends to be older and far less often accessed. Recently, a new tier of storage has evolved called Tier 0. This refers to high-performance, solid-state disks, which instead of using traditional hard drives, uses memory for storage. This is an order of magnitude faster and more expensive than traditional disks, but can add real value if used to accelerate high-performance applications. ILM does not come as a product, but is rather a set of rules and processes defined by the organization, then implemented using a range of technology options. In our example, the storage deployed 5 years ago is nearing full capacity. One option is to replace with a bigger system, but this would be expensive and not make best use of the existing SAN. Storage virtualization introduces a logical layer above the disk system. This enables the addition of storage arrays alongside the original. The total combined storage is represented as a single pool of storage, which just magically got bigger. In this way, the existing storage can be reused as part of the new virtualized solution. However, maybe we can avoid spending anything on new storage by getting a little smarter. Deduplication. Copies of data are replaced by small pointers to the primary source. Users see files in the network folders or email as usual, but in fact when opened, the system pulls the data from the primary source. Storage could be shrunk to perhaps 20% of the original. With multiple instances now removed, this means our backup to disk requirements may also shrink, as there is now less data to back up. Up to 80% of data is rarely accessed and is unchanging. This reference data is suitable for moving onto an archive tier. The beauty of an archive is that by definition it only changes as and when data is added to it, so reducing the regularity of backups needed. Using lower performance disks means costs can be reduced. Archive systems normally include indexing and search facilities which make finding and retrieval of information much easier. An audit trail can be enforced on changes and file deletion disallowed based on data retention policies. Compliance with legislation and corporate governance rules can be a driver in itself for adopting an archival system. Thin provisioning is technology which allows large storage to be allocated beyond the capacity of the physical disks installed. As long as actual disk usage is monitored and physical disk added when required, this is a great way of reducing upfront costs and saving space. Snapshots. Rather than copying to a second area of disk for backups, a lookup table is created which marks the current state of the data. As and when changes occur, these are recorded. This effectively freezes a point-in-time version of the data. Snapshots can be taken on a regular basis. Another advantage is if users inadvertently lose a file, it is relatively easy to roll back to a prior version of the data before the file was lost. If one snapshot were to be retained, the space required could be reduced down to say 10 or 15%. However, it can be advantageous to keep multiple snapshots, in which case space might even increase. By implementing a combination of technologies, we can see that DynoCare may avoid a costly storage upgrade for some time to come. We have taken a storage system which was close to full capacity and reduced usage down to about half. What is more, the rate of storage growth is severely curbed. The secondary site can be reduced even more because tiering means not all data needs replicating, and daily backups have become much easier to handle.